Okay, let's go through a little brain teaser that ties together some of the basic probability concepts we've already covered in previous videos. So let's read this problem statement. Event A can happen anytime between 0 and 1, uniformly distributed. That means any time between 0 and 1 is equally likely. PDF, the probability density function that we'll be using then, will be a constant value between 0 and 1 and 0 outside those limits. Event B is the same thing. It can happen anytime between 0 and 1, so the PDF is 1 between 0 and 1, 0 outside that. Why did I say 1? Because to be a PDF, it has to integrate to 1. And if it's equal value from 0 to 1, that means the height has to be 1. So that's what each of these guys, PDFs, probability density functions, will look like once we define them as random variables. And those two events are independent. What is the probability density function of the random variable that represents the absolute time between the two events? And you should pause your screen here and think about how you would go about doing this. The one hint I will give you is that you can't just dream up the answer. You can't just intuit. It's going to take a process. You're going to have to break things down and think about it. Go ahead and pause the screen while you do some thinking. A few things to get started. What you're going to want to do is deal with random variables. So let big X be the random variable of that event A, and big Y be the random variable of the time of that event B. And then Z will be a third random variable. It's basically a function of the other two random variables. It's the absolute time between them. So there will be this functional relationship between Z and these other two random variables. So what we seek is this PDF here of Z. And I'll give you one more hint while I'm on this chart. If we find the cumulative distribution function of Z, then all we need to do is take its derivative to find this PDF. So what we're really going to do is find the cumulative distribution function of Z. Pause your screen here again as you think about how you continue from here. So here's what I would do. Since we're asked, if what we're looking for is this guy here, cumulative distribution function of Z. We're looking for that because if we get there, all we need to do is take its derivative to find the PDF. But this guy, by definition, is this probability. This is the definition of what this thing means. But Z here is a function of these other two random variables, like this. Just plug in what Z means here. We can split it up here. We have the probability that involves two random variables. Remember how we did that? Region of integration. We integrate the joint PDF of the two variables, in this case, X and Y, integrate that over the region where this is true. What is that joint PDF? Well, since they're independent, it's the product of the individual PDFs. And they were just ones. So let's sketch what that joint PDF looks like. X goes from 0 to 1, Y goes from 0 to 1. It has to integrate, the whole thing has to integrate to 1. And it's constant because each of X and Y PDFs were constant. And the joint PDF is just a product of the individual PDFs. which were each one between 0 and 1. So the joint PDF is just this unit cube. And all it will mean to integrate over a region is to find the area of the region in the XY plane, and then multiply by this height, which is just 1. So all we need to do is find the area of this unit squared, where this is true. Let's keep going. So where is that true? It's two things have to be true simultaneously. Where were we? Z has to be less than or equal to x minus y, and it has to be greater than or equal to x minus y. Or x minus y has to be less than or equal to z. We can put both these in terms of put the y on the left side, so we can better graph it. And then it looks like this. This would be, let's see, y equals x plus or equal to x plus c. And this would be y greater than or equal to x minus c. So these are the two things that are true simultaneously. Let's see, y equals x plus c, that's this dashed line here. And y equals x minus c is this dashed line down here. Where are they both true? Think about it a little bit, but in here, in this shaded region here. Pick any z, and you'll have to pick a z between 0 and 1. And this is the shaded region. Integrate over. And all we have to do now is find the area of this shaded region. Now, the easy way to do it, I think, is 1 minus the area of these two clear regions. Just nice little triangles. So it's 1/2 the base times height. And in each case, the base is the same as the height, which is 1 minus z. That's true for both the top triangle and the bottom triangle. Think through all this because I kind of went through it fast. Go ahead and pause your screen until you're convinced of all this. So that's the area. So it simplifies to this. This is the joint distribution function of z. This is big F of z. Now all we need to do is take that derivative. There it is. Here is big F of z, the distribution function. Here's the little f of z, PDF, the probability density function. That was a nice little exercise, wasn't it? All based on very basic things we've already covered, but wasn't all that easy, was it? Go ahead and go over it again because you probably didn't get it the first time.